skip the how to say this decimal part. Decimal part. Skip the decimal part and just leave the integer part. Skip this one. And 4 already integer, so this is 4. Minus 1/2. The negative of 1/2 is here. Therefore, a minus 1. Or minus 1/2. The floor of this one, this floor is minus 1. Okay. This is the greatest integer function. The greatest integer of x is defined to be the largest integer that is less than or equal to x. So the next example. Example 10 requires us to show that when x approaches 3, this limit does not exist. Before doing this, I would like to sketch the graph of the greatest integer function. When x between 0 and 1, 0 is included. And the values are all 0, the left endpoint of this half open interval. Once x equals 1, already jump to this floor or this floor. This floor, so if x between 1 and 2, inclusively, exclusively, they are all 1. If x between 2 and 3, they are all 2s. All 3, all 4. Similarly, this is minus 0, minus 1, minus 2, minus 3. Y equals the greatest integer of x. And so forth. Certainly, because x is the maximum element in this set, so this one has this property. It's less than or equal to x. In fact, okay. So the graph of this one have to below Maybe some were the same height, but never exceed y equals x. Now, when x approaches 3, to show this limit does not exist, again, we consider one side of the limit, the two one-sided limits from the right and from the left. Okay, when x approaches 3 from the right, we consider a small neighborhood or an open interval, small, containing this one, but we ignore the value at here. So if the length of this neighborhood is less than 1, if x is greater than 3 and not more than 4, then this is part of a constant, the 3. So this is 3. From the left, again, this one ignored. To the left, we consider small interval, for example, with the radius 1. But this time on the left of 3. On this small interval, the values of this function is a constant function, a part of constant function is 2. By direct substitution rule, this is 2. Since the values of these two one-sided limits are different, we conclude the limit of the greatest integer of x as x approaches 3 does not exist. Okay? Yes? Okay. When x is less than 3, any x here, the greatest of x, the greatest integer of x is 2. Is 2. Because integers less than or equal to this one is 2, 1, 0, minus 1, minus 2. So the greatest one is 2. This is the reason why the value here is 2. Since we consider x nearby 3 and on the left of 3, we can consider only yes, the radius 1 or even smaller than 1. That's enough for us. It suffices for us to determine this limit. Okay? Yes, very good.这样有没有什么问题呢？我们在算极限的时候是看在你的附近，所以我们就可以考虑任何一个正的半径，方便起见，我们就考虑1就够了，甚至比1小也可以，比1大那可能会有跑出其他的值啊。考虑一个半径是1的这种附近或领域 neighborhood， 所以在这个地方呢，比3小的又比2大，所以这里面任何一点的最大长数都是2，这边都是2，这也就是为什么这个地方是2。当然，我们以前在高中就说，哦，比3小很靠近3，你们想2.9代代高，那就是2嘛，就可以做了。可是我们现在是希望说，你除了用代的之外，还可以说出一个理由。 就是这样子。Okay, this is example 10. The next example involving the trigonometric functions. Let's take a short break, and I will review some trigonometry. 下一个例题会用到三角函数，所以我们休息一下，之后复习一下我们三角函数，就是三角trigonometry。